Hello everyone, welcome back to our PySpark series. In today's video, we're exploring an essential SQL function in PySpark, the lead function. This function is incredibly useful when you need to access data from the next rows in a sequence, allowing you to perform comparisons, analyze trends, and even forecast future data points. We'll dive into how lead works, use cases, and some practical examples to help you understand how to harness its power for sequential data analysis. Let's get started. Introduction to the lead function. The lead function in PySpark is a window function that enables you to access data from the next row within a specified window. By using lead, you can retrieve values from upcoming rows, which is particularly useful for scenarios where you need to compare a current row with its subsequent row S. For example, you might use lead to analyze trends by comparing sales figures from one period to the next, track changes in values over time, or identify patterns by looking at future values relative to the current row. This function operates based on a defined order within the data, such as ordering by date, and returns the value from the next row in that sequence. If there is no subsequent row, lead typically returns null for that value. This makes lead especially valuable for data analysis tasks that involve forecasting, calculating future trends, or sequential comparisons. By accessing upcoming data points directly, lead provides a powerful way to conduct time-based or ordered data analysis within a single data frame. Basic syntax. In PySpark, the lead function is used with window specifications to access values from the next row within an ordered and partitioned dataset. The window specification defines how data is grouped and ordered for the lead operation. The partition by method divides data into groups based on a specified column, while order by arranges rows within each partition, typically by date or sequence. The lead function pulls values from the next row in the specified column with an optional offset indicating how many rows forward to look default is 1. For example, DataFrame.withColumn lead underscore column lead value underscore column offset 1 dot over window underscore spec creates a new column with values from the next row in value underscore column based on the defined window. This function is ideal for forecasting trend analysis or comparing sequential data points directly within a data frame. Why use lead? The lead function in PySpark is a valuable tool for scenarios where you need to compare current rows with future rows within a dataset. It allows you to access the next data point in an ordered sequence, making it particularly useful for trend prediction and change analysis. By using lead, you can retrieve future values in relation to each row, enabling you to identify patterns and changes between consecutive rows, which is essential in time-based or sequential data analysis. Practical examples. 1. Accessing the next row. In this example, we create a data frame with employee names and salaries and then use the lead function to access the salary from the next row based on an ordered sequence. The data frame consists of 4 rows, each containing an employee's name and their corresponding salary. To use lead, we first define a window specification using window.orderBySalary. This window orders the rows by the salary column in ascending order, which establishes the sequence PySpark will follow to determine which row comes next. The window.orderBy function is critical here, as it sets the order for lead to reference. Next, we create a new column, next underscore salary, which contains the salary from the next row in this ordered sequence. The lead salary 1 dot over window underscore spec expression tells PySpark to look 1 row ahead in the ordered window and retrieve the value of the salary column from that next row. If there's no subsequent row, e.g., for the last row in the data frame, lead returns a null value by default. When we call show, the data frame displays each employee's salary alongside the salary from the next row in the sequence. This approach is useful for comparing current and next row values within a dataset, making it ideal for analysis involving future comparisons, trend assessments, or forecasting based on sequential data points. 2. Using lead with a partition. In this example, we create a data frame that includes employee names, their respective departments, and salaries. We use the lead function to access the salary of the next employee within each department based on salary order. The data frame df underscore depth contains four rows with columns employee underscore name, department, and salary. To make lead work within department specific groups, we define a window specification using window.partition by department.order by salary. Here, partition by department divides the data into separate groups based on each department, like HR and finance. Within each department group, order by salary arranges employees in ascending order by salary. This setup ensures that lead will only access the next row's salary within the same department. Next, we add a new column called next underscore salary using lead salary one dot over window underscore spec. This command retrieves the salary from the following row within each department's ordered sequence. If an employee is the last in their department's order highest salary, lead will return null in the next underscore salary column for that row. When we display the result with show, the data frame shows each employee's salary along with the next salary in their department. This approach is useful for department-based comparisons such as identifying salary progression within departments, analyzing trends, or preparing department-specific forecasts based on sequential data points. 3. Calculating future change. In this example, we create a data frame with employee names and their salaries, and then use PySpark functions to calculate the difference in salary between each row and the next row when ordered by salary in descending order. The data frame df has two columns employee underscore name and salary. To calculate the difference in salary, we first define a window specification with window.order by call salary.dsc, which orders the rows by salary in descending order. This ordering determines the sequence in which PySpark will access rows from the highest salary to the lowest. Using this window, we add a column called next underscore salary by applying the lead function with an offset of 1. This command retrieves the salary from the next row in the descending order sequence, giving us the salary of the employee with the next lowest salary. If there's no subsequent row, as in the case of the last row in the ordered sequence, lead will return null. Next, we calculate the salary difference by creating a new column salary underscore change with the expression call next underscore salary call salary call salary. This expression subtracts the current row's salary from the next row's salary, showing the difference as you move down the ordered list. Finally, show displays each employee's salary along with the next salary in sequence and the calculated difference in salary underscore change. This setup is helpful for analyzing gaps or differences in salaries, observing trends as salaries decrease, and gaining insights into how salaries vary across different levels within the dataset. 4. Using lead with different offsets. In this example, we create a data frame with employee names and their respective salaries and use the lead function to access the salary from two rows ahead in a descending order sequence. The data frame df consists of two columns employee underscore name and salary. To use lead for retrieving values two rows ahead, we first define a window specification with window.order called salary.basic. This window orders the data by salary in descending order, arranging the employees from the highest to the lowest salary. This ordered sequence sets up the basis for determining which row lead will consider two rows ahead. Using this window specification, we create a new column salary underscore 2 underscore head by applying lead salary 2 dot over window underscore spec. Here, the lead function has an offset parameter set to 2, instructing PySpark to look two rows forward in the ordered sequence and retrieve the salary from that position. If there aren't enough rows ahead, for example, in the last two entries, lead will return null for these rows. When we use show, the data frame displays each employee's salary alongside the salary underscore to underscore head column, which contains the salary from two rows further down in the descending order. This approach is useful for broader comparisons, such as observing how values change over a larger sequence or detecting trends over multiple steps in ordered data. 5. Handling nulls with lead. In this example, we create a data frame with employee names and their salaries and use the lead function to retrieve the salary from the next row in a descending order sequence. Additionally, we set a default value for cases where there is no subsequent row, ensuring that the next underscore salary column displays consistent results even at the end of the ordered list. The data frame DF consists of two columns, employee underscore name and salary. To configure lead for accessing the next row, we first define a window specification using window.orderTheSalary.desi. This window orders the data by salary in descending order, arranging employees from the highest salary to the lowest. This order sequence allows lead to retrieve the value from the row with the next highest salary. In the new column next underscore salary, we use lead salary 1 0 dot over window underscore spec, where the lead function has an offset of 1 to indicate the next row and a default value of 0. If there is no next row available, such as for the employee with the lowest salary, lead will insert 0 instead of returning null, making it easier to work with the data without handling null values. When we call show, the data frame displays each employee's current salary alongside the next underscore salary column, which contains the salary from the next row in the descending order. For the last row, 0 is shown in place of a missing value, providing a consistent and clean dataset for further analysis, especially when working with sequences that may end with no additional rows available. This setup is particularly useful for cases where consistent default values are preferred for easier data handling and interpretation. And that wraps up our look at the lead function in PySpark SQL. I hope you found this guide helpful for understanding how lead can simplify accessing next rows and enhance your data analysis workflows. If you enjoyed the video, please give it a thumbs up, subscribe for more PySpark tutorials, and hit the notification bell so you don't miss our upcoming content. Thanks for watching and see you in the next video.